Hello. With this video I want to show you how you can transfer an animated driver from one car to another car. And yes, to show that I will use this skip barber from the dev mode. And there, I guess there are several methods how you can do that. This is my method and it works for me, so I think I can share it here. Okay, I have taken a steering wheel from another car already with its textures so that it can be loaded properly, and it's from a left-hand driven car, as you can see, and the skip barber, yes, as a single seater has the steering wheel centered, so we have to move the driver to match the position of the new steering wheel. Okay, before we start, I always prepare some things. First is I open the graphics GAN file and remove everything that is not necessary to be able to load the car in the dev mode. So I keep the driver, the helmet, all spindle and tire instances, the original steering wheel, and I keep the entry actor as vehicle, and I keep one mesh in the main slot, but I send it to render is false because I don't want to see it in the game. And I load out to 0 and I remove the shadow caster. Okay, and yeah, as you can see, I have added a new folder for the new driver here, and I will link that in the GAN file too, that the files that are stored in this folder can be loaded in the game and also in 3D SimEd. Yes, the skip barber entries are always a little bit strange. I restructure it always, in general I use another structure than this one here. Yes, I keep this entry that the game can find the CMaps mass file, and I will use one link to the main folder, one to the maps folder in this case, where the GMT and Texas are stored. And one entry for my new folder. So, okay. Yes, and because 3D SimEd ignores render is false, I modify this file name here with the underline that doesn't get loaded in 3D SimEd. Okay, Now I will save that file as a new file. I accidentally saved it already, but I normally save it as a new file and put an underline in front of it too, and put it into the folder where the other gain files are. And now I select one car, I take this skip barber 05, open the vehicle file, and also here put the underline under the file name of the graphics gain in the vehicle file, that this gain file gets loaded and not the original one, and save that here. Okay, now when I load the car, the animation should work and be visible. Yes. Okay. Now I will add another instance with the steering wheel of the new car. So I copy this one here, rename it, and the name is S wheel left. So now it should be visible too. Yes, there it is. As you can see, the positions are different and also the size. Of course, if you do that, you should search for an animation that matches as best as possible your steering wheel. Sometimes it's also necessary to modify the size a little bit, but it's in any case better than to have no animated driver. Okay, so far everything works here. Now, I don't know if you all knew 3D Zimet or work with it, but if you want to use that driver and helmet for your new car, you should also have all textures that it uses. As you can see here, there's a pink object. That means that the texture is could not be found, and the simple reason is that it is in the CMaps mass file that is in the vehicles folder directly. That is a common a common file which where the content of it gets used for every car that has uses some of these textures and what is in that mass file. And that is the case here. The textures for this object are in the CMaps mass file, so you can ignore that they are not shown here. But you can import as objects and go to the original maps folder, select the 3 driver files and the helmet, and the helmet. Open. As you can see, they are all textures, and now you can export textures and can export them to the to every folder that you want. In this case, I would suggest to extract it or to export it to the folder where also the new driver and everything else is stored. But I will not do that because I have linked the old maps folder in my GAN file, so the textures can be found. Okay, now I copy the 3 driver meshes from the original 3 driver meshes, and also the helmet, and also the animation file, that is this one here. Copy all of them and put them into the test driver folder too. So now we have it here. Now I will rename everything a little bit. Here I will replace RTER with new. For the helmet I will do the same. And here I will replace rF2 underline generic with new. Okay, that will be the new driver then. So I will change that here too now. So the names should match, and now these objects should be loaded when I load the car. We will not see any difference because that are the same files, just renamed. Okay, everything loads. Okay, now we load the steering wheel of the new car into a 3D ZimEd and go to the Edit tab here and open Face Data Attributes. As you can see here, it has a specified pivot point with the X, Y, Z values. So copy this whole entry here. Then open, yes, I use LibreOffice because the physics spreadsheet are made for this format. You can also use Excel or any calculation program that has this, that can handle what has to be calculated now. So I make an entry that is a new steering wheel. Then I write the coordinates are X, Y, Z. And I go to the new steering wheel cell that is under X, right click on it, select paste special, again paste special, and use text import dialog. Then click OK. As you can see here, every value is in a single cell because I have comma as a separator checked already here. If I uncheck it, you can see they would be put in one cell, but I want to have them in 3 single cells. So I check comma and OK. So now we have the X, Y, Z coordinates here from the new steering wheel. And now we do the same with this Barber steering wheel. Open that from the there it is. Okay, that is the original steering wheel. We again take the pivot point values here and do the same as before. in the cell for in the X cell for the original steering wheel. Again, paste special, use text support dialog, and OK. Okay, now we have the position of the new steering wheel and the position, the pivot point position of the original steering wheel. Normally, the driver, yes, is always positioned directly aligned to the position of the steering wheel. Yes, like it is in the normal life. And so we have now now we can calculate the difference between the new position and the original position. Yes, the main focus in this case is the X position, the left-right position, because the other values can vary, because the pivot point don't have to be necessarily inside of the steering wheel somewhere. It can be somewhere on the axis here. So yes, we care later for that. But for now we want to calculate the difference between this and that. And so we subtract the values from the original steering wheel from the values of the new steering wheel. That I will do in this line here. This is this minus that. Then select that cell, go on to this little mark here, click the left mouse button and move it to the right, that the formula gets put in these cells too. So that we now have the first movement values. So again, I load the vehicle. Okay, the driver is on the old position. Now I import the new driver, the high res model. Oh, that is at 000 standing. It must not be the case always. It can be that it's more to the left, to the right, up, or whatever. But it doesn't matter. The important thing is the pivot point that it has, because that has to be 0. And as you can see here, it doesn't have 0. But in this case, yeah, we don't care for that. Or better said, we don't care for that at all, because that is a position that it has to match the original steering wheel. So now we go to Edit, Translate, and move that by the values that we have calculated here, these 3 values here. So translate, and then 0.273729 minus 0.2135, then 0.223876. Okay, then we click OK, and as you can see, the driver mesh has moved to the new position. And now, and this is very important, we have to open the face data attributes tab again, this window, and set the pivot point to 0, 0, 0. Hit enter and click OK. Now this mesh has 0, 0, 0 as pivot point. Okay, now we export it. Of course, to the test driver folder and overwrite the existing mesh. Yes. And now we load the car again to see how it looks now. Okay, as you can see, now the driver is aligned to the steering wheel to the new steering wheel. And you can see how the hands move around. I think it's a little bit too much in front. Yes, by the way, keep this window open as long as you move the driver. So yes, because it's a little bit too much to the front, we move it a little bit backwards on the front rear axis, this is the Y axis, and enter that value here too. And I will move it by 0.02, that are 2 centimeters. And I will do the same thing here. Again, edit, translate, and then Y 0.02. That moves the driver a little bit to the rear. Again, very important, set this to 0. As you can see, the pivot point values have been affected also. So we have again set it to 0, 0, 0. Enter. OK. Export. And overwrite. Okay, now we load the car again. The steering wheels have different upright angles, so this animation doesn't match the steering wheel very good, but that is a method how you can position the driver. And don't forget, as long as you modify any of these values for the driver here, keep this window open and always enter the values that you use also here, because we need that for the final calculation of the of the movement. So for now I leave that as it is here, because it's good enough to demonstrate it, but as you can see, the helmet is still on the wrong position. But with that it is a little bit easier. So we import the new helmet also. And as you can see, it also has a specified pivot point that we have to keep, because that is a point around that the helmet rotates in game when the driver is driving to a curve. The good thing is when you import the helmet, and modify something or move it, the pivot point gets adapted to the movement and will kept. When you then export it, the pivot point is the new one and nothing gets lost. If you do that with import as objects and export it afterwards, all pivot points get lost if you do nothing to set them if you use import as objects. So I would always recommend to import the helmets to keep the pivot point. Okay, and now to get the values for the whole movement, I make a new line here and say that is the sum of these values. Of course the same. Again, mark that cell, go onto the little blue mark here, left click with the mouse and move it to the last cell that the formula get copied into the cells. And now we have the final movement values that we use for the helmet now. So just as a demonstration, I will copy the original values. And now let's translate it. That is 0.273729 minus 0.092135 0.223876. Okay, I again copy these values here. As you can see, the pivot point has changed according to the movement. So everything is fine here, and we can directly export that. And the helmet should be on the correct position there. New helmet, yes. And overwrite again. Then we load the car again. As you can see, the helmet is positioned properly too. Okay, if there are medium and low res poly helmets, you can do the same procedure here. For the drivers, because we always set the pivot point to 0 when they have been moved, as shown before. We can use the import as objects. Now the high poly driver is done already, so only the low and mid driver meshes are left. So import these two, go to translate, and also use the final values here. Okay, and I said, if you export them as objects directly without to mark all, and you can set tags here. All pivot points get automatically set to 0, so you can export and save rFactor to objects. Select the test driver folder again and say OK. Okay, now if we import the 3 driver meshes, they should all stay at the same position. Yes, they do. Okay, let's make a last try in game. To load it there, I have to rename the entry here that the mesh can be found, that there is no error message. Yes, and let us look how it looks in the game. If there are any distortions or something being wrong. I have no steering wheel connected. Yes, that's the keyboard steering, but as you can see, everything works and the position is the correct one too. Yes, okay, that is what I wanted to show you. Thank you for watching.